All right, good morning, class. Sorry for a little bit later discussion post this week. I was a little bit busy with a couple job interviews and school and whatnot. However, this week we're talking all about normal distributions. And first, I guess the best thing to start off with is the history of normal distribution. Normal distribution of Gaussian distribution was detected by Carl Friedrich Gauss in 1809, but it was rediscovered during the 19th century. And distribution was applied extensively in developing areas of probability and statistics, which obviously is what we're studying right now. The book's perspective, which I'm sure everybody is enlightened on already, is to talk about the normal behaviors of normal distribution, how it is symmetrical, and if you folded both sides of a normal distribution, they would fit perfectly and overlap. And I guess the best thing that the book really uses to describe is you took everybody in the world. You got extremely low IQs, middle level IQs, extremely high IQs, higher IQs, and you combined all those data points into a distribution. You would have a mathematical definition of normality based off of the intelligence of the entire population. And it should look something like a normal distribution. Now, some of the other ones that I found, and I'm going to try to pronounce his last name correctly, is Kerthricka-Dada. In normal distribution is the measure of central tendencies and the measure of dispersion. The measure of central tendency is the direction towards the centralmost value of the dataset and is given by the mean or median. The measure of dispersion includes standard deviation, standard error, and a confidence interval. Normal distribution is not only the ideal, it is the ideal distribution that is to be achieved. So it is the most perfect understanding of a data set that you can have to have a normal distribution. Braden describes it as usually normal distributions are compared by putting them on the same scale to obtain a standard normal distribution to do this. And he goes through some mathematical formula about how you subtract the experimental mean so that the new mean is shifted to 0 and divide the shifted data by the experimental standard deviation. And the standard deviation is the new data is now 1. And I guess that's the most perfect way of describing a normal distribution plot in terms of numbers. If you had a mean of 0, your standard distributions would be 1, 2, and 3 away. And most data sets that you'll see go along that, your normal distribution is going to be centralized on a mean, median point that you have, and then you're going to have a set of standard deviations away from that mean or median point that show you confidence intervals of, I'm 95% confident that most of my data points are going to be between these 2 points of the normal distribution distributed by the data that was given. Now, I don't know if my definition is going to please everybody in this class, but I found it a wonderful thought, to be completely honest, and thinking about Newton, and every action has an equal or opposite reaction. And I guess the fun thought that I really thought of for that is every action has an equal or opposite reaction, and then everything else in between. And I think that's the best way to describe normal distribution, as something, even an extremely low IQ, has an equal or opposite reaction of an extremely high IQ, and then you have everything in between, which describes normal distribution. And the other way I look at it is some sort of mathematical perfection. You can't have a normal distribution without declaring something perfect or having some sort of mathematical perfection. And in the world, obviously, not a whole lot of things trend to perfection or normal distribution. However, when you find that, you have found something that is significant. And I guess that's why normal distribution is so prevalent in our society, or at least in statistics and finding probability of things happening. Second, justify your definition by using the sources of information you've identified. Between all the sources that I found, everybody described normal distribution is standard deviations away from the mean. They fit exactly together. I think mathematical perfection describes that, and having equal or opposite reactions. I don't think it's the most perfect way of describing normal distribution, but I think it's the most fun way of describing normal distribution. Finally, the end of part of this was to find an aviation-related research article that uses normal distribution and normality, and summarize and explain why the analysis might not be valid if distributions were assumed to be normal. I found this really interesting article, and I guess it's not completely about aviation. However, it is about precipitation trends and types based off of normal probability models. And I found it to be really fascinating, so I did want to share it. And this article and data set was all based off of predicting types of precipitation based off of a predictive vertical wet bulb temperature profile and pressure levels and thermodynamic values. So what this research team did was took a bunch of different readings throughout the year and collected a whole bunch of different data points from a vertical wet bulb temperature profile and looked at the pressure levels and the thermodynamic variables and put them into a wide range of histograms and data plots, and actually found a way to predict times of years for certain places, what types of precipitation would be most likely in an area. And the reason I find that applicable to the aviation industry is if you're an airport and you wanted to understand what kind of weather will be coming, at least in a 7-day forecast, or for a specific time of year for a place, you could use these predictive normality distributions to understand what the probability of a specific type of weather or a specific type of precipitation in the area actually is, especially snow, which causes a lot of hardship for the aviation industry. So now, explain why the analysis may not be valid. There's a lot of factors that need to be taken in to determine the types of precipitation for a specific period of time. Now, that being said, this research does describe that these normal distribution models and predictive methods are good for 7-day forecasts. Understanding this is what's happening at this point. Let me go to the data. Let me look at what the normal distribution is and my confidence level about what it could be, which I feel like a lot of weather prediction does anyways, and compare it to previous models. Now, obviously, we can all know how a weatherman is incorrect sometimes. And that's where it comes into. Explain why the analysis may not be valid. You cannot predict 100% what type of precipitation is becoming which day, or what weather is going to happen which day. There's always some sort of error associated, even with a 99% confidence level. So that's something to take into fruition, I guess, going through this class. I hope everybody enjoyed. Have a wonderful weekend.